All right, hi everyone. It's Nick Marshall here with the vBrownbag crew. I want to welcome you here tonight. We've got GS Khalsa on the line to talk about availability in vSphere 6. But before we get started, let me just give a few quick notes. We've obviously got a number of brown bags around the world, including Latin America, Europe, APAC. You can see the times and availability there. As I said, we've got GS on the line. I'm Nick Marshall, and we're going to have a blast tonight. Welcome, GS. How's it going?
It's great. How about you, Nick?
I am well. I am stoked because on Monday my new book comes out, so I am happy that that long road is behind me and I can relax for the next couple of years before I write another one. But
Good deal.
Everybody's
looking forward to getting their hands on that.
Well, hopefully you'll be able to share a little bit about some of the stuff that I've written about. But yeah, I'll hand it over to you, and you can tell us all about the stuff that you've been working on. So let me flick this over and make you the presenter.
Okay. Okay, so are you seeing
We
my
are.
slides or the presenter view?
Oh, no, we see your slides.
Okay, great. Okay.
And before you get started, I just want to let everybody know, follow along on vBrownbag, hash vBrownbag on Twitter, and I will relay your questions to GS or in the chat within GoToWebinar, and I will stop GS halfway through mid-sentence and interrupt him as all good hosts do. Take it away, GS.
And please do send in your questions. I would love for this to be more interactive. It's a lot more fun when I get to go off the slides and get into cul-de-sacs and random topics and things like that. So yeah, throw your questions out there. I'd love to answer them. So let's talk availability. We'll talk FT, HA, a little bit of VR, a little bit of SRM. Those are all things that I'm directly responsible for, or at least HA and FT I was responsible for up until a couple of weeks ago, but I put all this material together, so that's why I'm presenting it. So FT, I'm going to assume that everyone is familiar with the old FT, the idea that you run two VMs at the same time on different hosts. They have the same IP address, same MAC address, same, everything is exactly the same on both of them. One host goes down, the VM the primary that's running on that host goes down, the secondary picks up, and you don't miss a beat. You don't drop any packets. Your applications keep running exactly as if nothing had ever happened. So the big limitation that everybody's aware of before was that FT only supported one vCPU, and I used to call it the coolest feature that nobody used because, how many workloads do you have that only use one vCPU? And we actually did have customers that used it, just not very many. So we've been working on a complete revamp of FT for years now, and it's an incredibly complicated engineering problem. And our awesome engineers at VMware have, they've been working at it for a while, and we're finally ready with 4 vCPU, supporting up to 4 vCPU VMs. So 4 vCPUs, 64 gigs of memory. You can have a maximum of either 8 vCPUs or 4 FT protected VMs per host. So keep in mind that those limits are user customizable. So if for some reason you feel like you want to run more than that, there's nothing stopping you from changing that. I wouldn't recommend changing it on a whim, but you're perfectly able to do that. So a couple other new things that we added to FT, the ability to back up FT VMs. So traditionally, you weren't able to snapshot FT VMs. Just to be clear, you are not a user. There's no way for a user to directly snapshot an FT-protected VM. However, if you're using a backup solution that uses VADP, VMware APIs for data protection, and you can see our NASCAR slide of just a few of the vendors that we're thinking of here that do this. If you're using a solution like that, those solutions are able to snapshot and back up FT-protected VMs. Another thing is storage. The previous version of FT used the same storage. So you had two hosts both working off of the same storage, so that your storage was a single point of failure. In the new FT, your storage is now redundant. So you have a complete copy of your primary and your secondary VM, VMX files, VMDKs, the whole thing. So you no longer, your storage is no longer, or that data store where your VM is stored on is no longer a single point of failure.
Hey, I've got a question about that.
Come up
yes.
A little bit in. Yeah.
So does that mean?
I've been on my way to answering it.
Well, maybe not. So you've got two copies of the VMDKs. Does that mean they have to be on different data stores, or you've got down there allowed to be on different data stores? Does the policy force that? Does it recommend it?
It will recommend it. You can put them both on the same data store if you want to.
Okay.
It will warn you about that, though. And I would highly recommend that you put them on different data stores. The thing to keep in mind with those VMDKs is, since there are two copies of them, you are talking about double your IOPS. So, and the couple, I'll get into more of these later, but as with any kind of, fault-tolerant lockstep solution, the system is going to run basically at the speed of the slower system. So if you run your primary storage on SSDs and your secondary storage on, some 3 terabyte SATA drives, your VM is going to run as slow as those SATA drives, not as fast as those SSDs.
Okay, I've got a couple of questions about that before you head on. I've got two people are asking, can FT support vVol-based storage?
Not currently.
Not currently. And the question that I had was it's not really a question, it's a statement. If they're doing twice the amount of storage requirements, does it hook into the VASA provider to understand if it's on like a deduplicated backend array, or how? Because what I'm thinking is, if you're starting to enable SMP-FT on a number of VMs, you're going to have to take into consideration the storage requirements from a design perspective, right?
Definitely. Yeah, there's currently no direct integration with VASA. But if you're, think about that. If your array, whatever capabilities your array has already, just in terms of deduplication, tiering, things like that, would get applied to FTVM, FT storage, just the same as if they were other VMs. They wouldn't get applied like linked clones, for example, but it would, any capabilities that the storage had should still work with FT. Like, there's nothing that would break that functionality. Does that make sense?
Yeah, that makes sense.
Okay. One other thing that I wanted to mention with, I'll get into it in just a second. Let me just hit a couple of the other new features and interop first. So one of the other big things as far as new stuff with FT is the previous version of FT required either zero thick disks, and the new FT you can run it on thin, thick, or either zero thick, just depends on what you want. You can now also hot configure FT. It used to be that you had to turn it on, enable FT when the VM was turned off. So you can turn on and off FT now with the VM running. And from a host compatibility standpoint, with the previous version of FT, it was really particular about requirements for what it would run on. And it would require, you had to have the same, wasn't just like the same processor company, but it was almost like the same processor family. And in some cases, you could get down to like the same processor speed, because you were executing the same command processor instructions on both VMs, on both hosts. So with the new FT, if your hosts are vMotion compatible, then more than likely they're FT compatible. So whole lot easier to use. This is kind of an eye chart, just showing FT before and after 6.0 capabilities, things that it can and can't do. A couple of things that I just want to call out is FT is previously was compatible with SRM. The new FT is currently not compatible with SRM. And previously, the way that it worked is you could protect an FT protected VM with SRM, and when it was recovered on the recovery site, it would just be recovered as a normal VM. We're still working through some issues there with the new FT and protecting it, but a few things that the old FT didn't work with and the new one doesn't work with as well: storage DRF, vSAN, vVols, VCB, vSphere replication, and stress clusters. Stress clusters is something that you could theoretically try. There's nothing that is going to stop you from enabling FT across a stretch cluster. It's just more from a performance standpoint and a testing standpoint that that wasn't something that we could certify. So for upgrading FT, if you desire to still use the old FT, you can run legacy FT VMs in vSphere 6. If you upgrade the host that they're running on and you just don't do anything to the VM itself, if it was FT enabled in vSphere 5.x, when you turn that VM on in vSphere 6, it's still going to use it'll use the legacy FT. If you want to upgrade it, it's just as simple as turning FT off and turning it back on, and at that point it would be enabled with the new FT.
And that you can turn it on without having to reboot now, right?
Exactly, yeah. Well, with the old FT, you still have to turn it off. To turn it off, you're going to need to turn off the VM.
Sure.
So, and then if you really want, for whatever reason, if you want to still use legacy FT, there's you can edit the VMX file, and I've got that listed here. I'll probably put that in a blog post or something sometime soon. But there's it's a VM advanced option. That's what it is. There's a VM advanced option, vm.use legacy FT equals true.
So does enabling the legacy fault tolerance technology, is that count towards the maximum of 8 protected vCPUs? Well, the 8 maximum fault tolerance CPUs. It doesn't matter which technology you're using, it's still a maximum of 8 vCPUs per host.
Yeah, and keep in mind that that's user customizable. So if the user wants to change that, they're perfectly capable. They're able to do that if they want to. The limit of 4 vCPU VMs, that is a hard limit. You can't enable FT on, say, an 8 vCPU VM, but the limit in terms of number of FT protected VMs, a number of FT protected vCPUs on a host is user customizable. And then if you're curious, one other thing is if you're curious about Say you've got some legacy FT protected VMs and some new ones, and you're not sure, which are which. If you look in the VMX log file for the primary or the secondary, if you do a search for ftcpt.enabled, if that's present and is set to true, then that's a multiprocessor FTVM. Otherwise, it's a uniprocessor. So just a little bit about the FT technology, how it works. I've talked a little bit about this already, but this is a complete rewrite from a technology standpoint. And really, in a nutshell, the way that fast checkpointing works is it's very similar to an X vMotion. So, a combined storage and regular vMotion that never ends is a good way to think of it. And everything is just happening a whole lot faster and in a more highly optimized way. So basically, during a vMotion, you're going to create a second VM on the destination host, and then you're going to start copying the memory of your source VM to that destination. And then in regular vMotion, checkpoint data is the last bit of memory that keeps changing. And you're going to have to, while you're sending that, you have to pause the source VM in order to access that memory. And you want to try and keep that pause as short as possible. And then once you copy over that last bit of active memory, then you start that secondary VM. So with FT, you're continuously copying over that checkpoint. And this kind of gets to one of the things I'll visit a little bit later, that the reason that FT has a requirement of 10 gig networking. And the reason that we require that is because we need to perform a whole lot of checkpoints every second, and you want to minimize the performance impact on that primary VM.
So it's definitely a requirement then. I think I might have mentioned last week that it was a strong recommendation, but you're saying it's a definite requirement. Is it a hard requirement or a soft requirement?
To be honest, I'm not exactly sure if it's a hard requirement or soft. I think if you're running FT and you're using 1 gig networking and you call it support, I think they will try and help you. But if you're calling up because something isn't performing well, they're going to tell you need 10 gig networking. Yeah.
See, I was being non-polite, saying they're going to laugh at you, but no, the polite way is saying that they're going to.
Yeah, they probably will do that too, but they'll tell you need 10 gig networking. It's not a definite thing, but the average FT protected VM is going to consume more than 1 gig of bandwidth. So that's where that requirement comes from. Is that 1 gig of networking just really is not going to keep up. And the result of a limit in bandwidth is going to be that your VMs are just going to perform poorly.
So again, those people that are doing VCDX designs on vSphere 6 are going to need to take this into consideration when they're designing their network, the network IO control 3 stuff, to ensure that fault tolerance becomes a first-class citizen again. Because everybody just says, oh, well, we don't use fault tolerance. But if you're going to use it in vSphere 6, it's something that you need to design around.
Yeah. And you want to think about where you play, the neighbors that you put it with, because things like vMotion, the vMotion network is probably a bad thing for FT to share a network with, because of how much bandwidth the both of those are going to end up using. So just a little bit more about the actual process of FT. So the checkpoint is a snapshot of your VM state. And just like with the VM snapshot that you can request from the UI, an FT checkpoint contains the content of your VM memory, your disks, your devices, VMX config options at the time of that snapshot. Unlike a regular snapshot, an FT checkpoint only contains the incremental VM state changes since the last FT checkpoint. So disk writes, so every I/O is going to get mirrored on both. And the thing that uses that is the SV Motion mirror driver during the initial FT migration. So that's when that secondary VM is getting powered on. After that, FT is going to use its own disk write mirroring code. And the checkpoint interval is going to be dynamic. So it's going to adapt to maximize the workload performance and can range from as little as a few milliseconds to as large as several hundred milliseconds. So we already kind of talked a little bit about network impacts, but I just want to, this slide just is going to emphasize a point, and that's that packets are, so when a packet arrives on the primary, that has to get, before an acknowledgement goes out for that, the receipt of that packet, the primary VM is going to get paused or frozen. We're going to send that checkpoint over to the secondary. The secondary is going to send an acknowledgement that it received that. And at that point, the primary is going to get unfrozen, and the acknowledgement for that packet goes back out. So that should give you a good idea of why FT is not really a good candidate for things, for workloads that are latency sensitive. And by latency sensitive, I mean like really latency sensitive. So FT is going to increase your latency a little bit. It's going to increase from maybe a few milliseconds, possibly to as many as 100 milliseconds. So if you're doing something like VoIP or high frequency trading, something like that.
Just hold on, John. John White's got a question, GS.
Yeah.
You there, John? I've unmuted you, John.
Sorry. Can you hear me now?
Yeah, we can.
Yeah.
I'm just wondering whether there's a tool ahead of time that can be used to profile data over, kind of some period of time that can give us insight about how much bandwidth FT would use were it to be turned on. Kind of as like a, one of those, using data to actually do a design as opposed to, oh, I think it's going to be this much.
Yeah. Currently, there is not. The only way to really do that at this point is to turn on FT and see what that bandwidth looks like.
So if somebody in the community wants to build a tool.
Yeah. If you have a test environment somewhere where you can enable, that you're running a workload that's similar to your production workload, and you can run a test of it beforehand, obviously that would be a good way to go. But yeah, unfortunately, we don't currently have a way of simulating that. And we are working on, and it should be released soon, a FT performance white paper that will go into a lot of detail about different workloads. I'm pretty sure it's going to talk about, at least to some extent, about latency bandwidth requirements, things like that. But hopefully that paper will answer a lot of those kind of questions, at least in a general sense. Really, though, what it's going to come down to, if you really want to get a good idea, though, is just enabling it. I'll have to check with the engineers about if that's something that they looked at or considered doing some kind of a tool like the vSphere replication tool, where it's kind of like you're enabling vSphere replication without really enabling vSphere replication. Just getting an idea of what the bandwidth is going to be like. So, thanks for that question, though. So let's talk just a little bit about shared files. There's been a lot of questions I've dealt with about some confusion around shared files with FT. So there's a few files that have to be on shared storage, and those are the FT configuration file, that's that shared.vmft, the .ft generation file, which is the tiebreaker file for the two hosts, and the primary VM VMX file. So those three files have to be on shared storage. If you really want to, you can store your primary and or your secondary VMDKs on local storage, or storage that is not accessible by all of your hosts. The big caveat to that, and the big caution that I would, big thing that I would caution everyone about is, let's just say, theoretically we take, we have a 3-host cluster, and we put our primary VMs, VMDKs on host A, and we put our secondary VMs, VMDKs on host B, and host A fails. Host B is the VM on host B is going to take over right away. That part's going to function just fine. But until host A becomes available again, FT is not going to be able to create a new FT, turn up a new secondary. Even though you have a working host in host C, because those the VMDKs are stored on host A, FT doesn't have a way of recreating those files. So when you pick where you're going to store your, where you're going to place your storage, when you turn on FT, that's where the storage is going to stay for as long as FT is enabled. So, and FT does not support storage vMotion, so that really is where those files are going to stay. So hopefully that makes sense. Just one of those cautions, something to think about.
There's a question. There's a question in the chat, GS. Does it matter, or does it make a performance difference where the swap file is placed for FTVMs?
Not that I can think of. I mean, no difference than it would on a regular VM.
Okay, thanks.
So for one of the things that I wanted to talk about is requirements, or just responsibilities. Which components are responsible for what. So vCenter is where you're going to have, that's going to define your workflows, and that's obviously where the user is going to be able to enable FT. It's going to validate FT compatibility, and it's going to handle things, interoperation with BADP, DRS, all those kind of things. That said, there's no requirement for, once you enable FT, FT does not rely at all on vCenter. So if you lost vCenter for some reason, that's going to have no impact on FT, other than the fact that you wouldn't be able to turn off FT if that's what you wanted to do. So it's actually HA, also known as the FDM, that's responsible for creating and starting a new secondary when that's needed, and restarting the secondary, reestablishing FT protection after a failover. And then the host itself is going to be what detects failures and initiates that FT failover. And the way that failure works is, and you have, the primary host fails, failure happens. The secondary is going to immediately change over to become primary. And then HA is going to start a new secondary on a new host. HA is going to initiate the FT migration from the primary to the secondary, get FT going again, and then at that point you're back where you were when you started. So talking a little bit about good applications for FT. So any application or operating system that's supported on vSphere is supported on FT. Whatever application you're using, there's nothing that FT does that limits you from an application standpoint in terms of just being able to use FT. FT is not dependent on any agents. It's not dependent on any, not dependent on anything at the VM level. That said, there is overhead to FT. You know, we've already talked a little bit about things from a latency standpoint, and the thing to keep in mind with the overhead that FT creates is that overhead is felt at the application level of the VM. So the example that I like to give is if you have a VM that right now is running, you know, say is capable of doing 1,000 transactions a minute or a second, something like that. When you enable FT, the overhead that you're going to experience is going to reduce the number, may reduce the number of transactions that VM is able to handle. You may go from being able to do 1,000 down to 900, or it may be less. The big thing is you just need to test that and verify that that it's going to work for you. I mentioned before that we are going to have a performance paper coming out soon that we'll get into a lot more specifics there. But the best thing to do right now is just test it out and see if it works for you, see if it meets your requirements. And if it does, then great. And if not, then FT is probably not the tool for you. Other thing to think about from when and where to use FT is there's lots of applications, or there's lots of alternatives when it comes to getting higher availability. You've got Microsoft Cluster, you've got Oracle RAC. The thing to think about with that, FT is not a replacement for those technologies. Just to be clear, FT is going to protect you from host failures. If your application crashes on your protected FT VM, it's going to crash on the secondary VM just the same. So it's not doing anything to protect you from application issues. But the thing that FT does have is it is giving you that host level protection. It's incredibly easy to set up and configure and run. You don't have to install the agents, you don't have to mess around, you don't have to do anything like that. You just enable FT, and you've got that measure of additional protection. And if whatever your licensing level is, I can't remember, I don't know what the licensing levels are for FT, when you can use which functionality, but if you have that licensing is usually a lot cheaper than a solution like Microsoft Cluster or Oracle RAC, things like that. So just some things to think about when you're looking at where to use FT, what's a good use case, what's not.
I can talk about the fault tolerance licensing, GS. So just for those out there, vSphere Standard will let you do 2 vCPU fault tolerance. Enterprise will also let you do 2 vCPU fault tolerance, and Enterprise Plus will let you do 4 vCPU fault tolerance. So the total amount per host is still the same, so it's still 8 per host, 8 total vCPUs per host, but you can't do 4 vCPU VMs unless you've got Enterprise Plus.
Okay, thanks for that, Nick. We pretty much already talked about this. Workloads that are latency sensitive, real-time, near real-time requirements, those are not going to be a good fit for FT. Just straight up that. Those are the only things, though, that I would say, if you ask me what isn't a good fit for FT, that's the only thing that I'm going to come out and say that is the case. That's not to say that there aren't other things. It's just that's the only one that I can say across the board is not going to be a good idea. A few other things to think about from a storage standpoint. Make sure your storage and your connectivity to your storage for those FT shared files is highly reliable. The reason for that is, as you can probably imagine, if the FT protected VMs lose access to those shared files, odd things can happen. Just like if your FT, if your regular VM lost access to its storage, strange things can happen. So make sure that stuff is highly reliable. We already mentioned the idea that the primary is going to run at the speed of your slowest component. And we already talked a bit about the MDK locations, about just, you can store them on local storage. I really would not recommend it. So networking, the recommendation is for a dedicated 10 gig VM kernel port. That said, you can use NIOC to share that connection, but just make sure that FT gets all the bandwidth that it's going to need. And you do have the ability to monitor the FT logging network utilization. So that's something that's just going to show up in each VM. In the config page for each VM, you'll have a thing showing where the primary and the secondary are running and what the FT bandwidth utilization is for each one of those VMs. And then obviously you can monitor it for the host as well. So a couple of things to talk about for processors. Newer hardware we've seen make a big difference. This will probably get outlined in detail in the performance paper that's forthcoming. But just to give you a theoretical example, let's say that we have a Sandy Bridge processor, non-FT protected VM that's doing 1,000 transactions a minute. We take the same VM still running on Sandy Bridge and we enable FT and say maybe that takes it down to 700 transactions per minute. If we ran that same VM on a Haswell processor with FT enabled, maybe we'd be getting 900 to 1,200 transactions a minute. So it's possible that you would end up, with a Haswell processor, you may end up with even higher performance even with FT enabled. So just some things to weigh there. One of the things to think about too is, if you've got a 2 vCPU VM and you're going to enable FT, if the performance, if you enable it and the performance isn't what you want, you can add additional vCPUs, and that may get you back up to your required performance. So just a couple of things to think about there. From a load balancing standpoint, and I probably should have made this point earlier as well, but those limits of the number of FT protected VMs on and protected vCPUs, the primary and secondary VMs count towards those limits. So you're going to have to keep that in mind when you're looking at putting those workloads in. And then also, when you think about load balancing, you want to, the bandwidth requirements for primaries and secondaries are really different. So you want to make sure that you spread those out. So you want to just keep, if you've got a 3-host cluster and you're running, 3 FT protected VMs, just try and put the primary and a secondary on each host, and that should balance things out nicely.
So just to clarify, GS, so what you're saying is if you've got 2 hosts and 2 VMs that are both for vCPU that you want to enable, you have one VM on one host, the other VM on the other host. So the primary is on one, the secondary is on the other, and vice versa. Those 2
Exactly.
VMs would count for your 8 vCPU FT total available for those 2 hosts. Is that right?
That's correct. Yeah.
Okay.
Okay, so that's FT. Let's talk a little bit about HA. So I'm pretty sure that everybody is aware of what HA does. The one thing that I want to point out that I do find a fair enough portion of people are not aware of, everybody knows that HA protects you from host failure. The new thing is that HA, well, not new, this has been around for a while. The one that people aren't aware of is that HA will protect you from operating system failure. If your VM has a has a blue screen and fails, HA can protect you from that. It will restart your VM, and one of the cooler features that I've ever seen is the HA engineers actually programmed it to, when it restarts your VM because of a VM failure, an operating system failure, it will actually take a screenshot of that blue screen, whatever was on the screen right before it restarted it. So I'm not going to talk a whole lot about that today. The big thing that I want to talk about in the new feature in HA is the ability for HA to deal with storage connectivity issues. So APD and PDL all pass down on permanent device loss. So a little bit of description. What are PDL and APD? They're ESX storage device states that indicate a device isn't available. And they really are, PDL is a permanent, it's a state that says this is permanently unavailable. APD is just, this is gone, and I don't know where it went. So how do you get a PDL and how do you get an APD? A PDL would be, let's say that on your storage array, somebody removed a host from a storage group. So basically told the array, hey, stop talking to this host. And what would happen is that the host would, keep sending its storage IOs to the array, and the array, as soon as that change was made, the array would send a SCSI sense code that basically said, you're not, it would trigger a permanent device loss because it would actually get a code back that says, you are never going to be able to talk to this device again. An APD, on the other hand, is just when a host loses connectivity to something. So, a fiber channel card goes bad, cables are cut, fiber channel switches fail, something along those lines. And all of a sudden, the host just can't talk to a piece of storage that it was talking to before. So before now, the way that APDs and PDLs were handled weren't great. There really wasn't support for APD handling. The support for PDLs was, it was added in 5.1, had some complex setup and requirements, and it just wasn't ideal. So in 6.0, we've got this idea of VM component protection. So when you have, you've got fiber channel storage, you've got iSCSI storage, you have an APD, a fiber channel card failure or something like that, that primary, the VM on one host is going to fail, and then HA is going to look for a host that doesn't have that connectivity issue and bring that VM up on that host. And same thing for a PDL. The host gets removed from the array storage group, the VM's going to crash, the VM's going to get brought up on another good host. And a few things to think about with APDs and PDLs and why they were a big problem and why we wanted to deal with this is that when you have these problems, despite what you might think, if you've ever pulled the storage from a VM, if you've ever just pulled its disks out, the VM does not crash. It doesn't just all of a sudden stop running. It'll actually sit there and it's kind of like a weird, almost a zombie state for a fairly long, it can be for a long time, just not working. You might even still be able to ping it. It might respond to those pings, but it's for all intents and purposes, it's dead. So it's almost, it really is like in a zombie state. So vMCP is going to detect when you have VMs that have those kind of issues. It's specifically looking for data store connectivity and keeping track of what VMs are running are dependent on what data stores, on what hosts. And when it sees an issue with a data store and it sees that get impacted by either an APD or a PDL, it jumps into action and takes care of it.
So the big question, GS, just go back one slide.
Yeah.
There's a significant thing missing. Can you tell me what it is?
NFS storage?
Yeah. Do you want to? There's a question from Graham Mitchell. No NFS love for VCMP. For vMCP.
So just to be clear, vMCP works with NFS storage. The only reason that I didn't include it here is that with NFS storage, you don't have the concept of a PDL. It's not a block level storage, so you don't have SCSI sense codes that are getting sent from an array to a host. But vMCP protection from APD works totally fine with NFS storage, just to be clear.
Awesome, thank you.
Hopefully that answered his question. So one of the other things, and this really isn't specific to vSphere 6, but this is something that we came out with recently, and it's directly related to HA. And this is, we've been asked a lot, how do I know what is going to happen when an HA event occurs? When I have a host failure, how are the rest of my VMs going to perform? And one of the things that people are often unclear about with HA is even with admission control enabled, even with HA enabled, HA does not guarantee performance of your VMs. The thing that HA is going to do is it's going to guarantee that your VMs can be restarted. Now, if your VM has a reservation, HA will make sure that that reservation gets met, and that gets to the admission control thing. But let's say that you have 100 VMs in your environment and none of them have reservations. All that HA is going to do is HA is just going to make sure that you have enough resources for whatever admission control policy that you've selected, that you have enough resources for those VMs to just be able to start running. And if you think about what the requirements are for a VM to just be able to start, they're pretty minimal. It's a tiny amount of RAM, it's a tiny amount of CPU. So the whole idea with this fling was giving users, being able to tell users how your VMs are going to perform if you have failures. So, and previously we had to tell people, well, you could put a host in maintenance mode, and that's going to tell you how the rest of your cluster is going to perform. But that doesn't, that's not a great solution. It's not an ideal use case because, what if doing that impacts the performance of your VMs and impacts your business? So the whole idea with this fling, and it works with all the way back to 5.0, so 5.0, 5.1, 5.5. You take your DRS dump file, you upload it into the VRAS, so vSphere Resource and Availability Service. This is just a URL, labs.vmware.com/fling/VM Resource and Availability Service. You throw the DRS dump file in there, and then you pick what kind of a scenario you want to run. If you just want to do a single host failure, you want to do multiple host failures, and it will show you what the impact is going to be to your VMs. So kind of what this looks like is you upload the file, you select what host you want to simulate failure for, and it's going to show you your estimated performance impact. It's going to show you, how many VMs are in your clusters, what VMs are not going to restart, what VMs are going to start but have reduced resources, and what VMs are going to be minimally affected. And you've got as much detail as you want of each one of those categories of VMs, and specifically what that impact is going to look like. I don't think I'm going to get into that. I'll talk a little bit about the recovery workflow. So the way that vMCP works, it's going to detect a storage failure. It's going to calculate the list of affected VMs. So if it's a PDL situation, it's just going to immediately terminate those VMs, and then those VMs are going to get restarted on another host. If it's an APD, it's going to wait for an APD declaration. And what that means is that there's a timeout period first that the host has, and then as part of the VM, the host timeout, I've written this down, the host timeout is, I think it's like 120 seconds. So it's going to wait for that timeout first, and then there's a user-defined timeout where you can set that to whatever you want. The default is 3 minutes. You could set it down to 0 if you wanted to, and that's basically just giving time for the storage to come back on its own. One thing that you can configure with vMCP is you can have it reset VMs in the case that if you do have an APD and it comes back before it declares a failure. Because usually, even if the storage comes back, those VMs are going to be in that zombie state. So it's going to wait for that APD declaration. If your APD is still occurring, if it's not, it's just going to, that's what I was talking about, it's just going to restart the guest. If it is, do you have failover capacity? If you do, it's going to terminate the VMs, they'll get restarted. If you don't, it just goes back through that cycle again. And vMCP, there's specifically for APD, it has there's an option of either aggressive or conservative failover. And the difference between those is a conservative failover would be where HA is going to make sure that it has a place to restart that VM before it terminates it. And an aggressive would be it's going to restart the VM and then figure out if it has a place for it. So it just kind of depends on what your environment is like, how you want to configure that. But that's the difference between those two.
It's 140 seconds, by the way.
Integrate.
APD is 140 seconds by default.
Yeah, thanks. Yeah. I knew it was somewhere around there. But vSAN integration, it really is kind of a different thing, because of the way that vSAN functions. vMCP, it really isn't going to be as much of a help. vSAN already kind of has that integrated into it. And I'm not going to really talk about the FT thing, just in the interest of time. So let's talk just briefly about what's new in vSphere replication. One of the biggest things is increased scale. Since we introduced vSphere replication, the limit has always been 500 VMs. With 6.0, we're now supporting replicating up to 2,000 VMs per vCenter. So that's really big. Keep in mind, though, you're still you still have to get all of the bandwidth. You still have to get all of the data from all these replicated VMs across whatever size pipe you have. So if you've got 2,000 VMs in your environment and you turn VR on for all of them all at the same time and set your RPO to 15 minutes for all of them, more than likely you're going to run into some problems. So just, I don't think we have any specific guidelines out there right now, but we're working on some. But you know, set your RPOs to where they need to be, not where you want them to be, would be my advice with that. And that really went, it was the same thing with VR, even when the limit was 500. But with taking that limit up to 2,000, it just really makes it a bigger difference. VR now supports end-to-end network compression, so you're basically trading a little bit of increased CPU for reduced network bandwidth. You can now do network traffic isolation, so you can. It used to be that VR used the host management network. You can now put all of your VR traffic onto a specific VM kernel interface. And VR now also supports file system QSing for Linux.
I actually think that's the biggest. In my opinion, that is the biggest thing, because that doesn't just isn't just for vSphere replication, but that's for VDP as well, and for any VADP based backup system. So any third party that uses VADP APIs, that's huge.
Yeah, and one thing that I wanted to point out too, I don't know if it's gotten brought up before, but I'm chiding myself for not including it in this, talking about this specifically, but one of the things with vSphere 6, the other change from an availability standpoint is VDP. It used to be there was a VDP advanced product. So all of that was a purchasable product. So with vSphere 6, all of the functionality of VDP is now available with Essentials plus licensing and higher. So that's agents for things like SQL, SharePoint, I know there's a few other ones that I'm thinking of. Oh, Exchange, yeah. You know, support for replicating your backups between VDP appliances, integration with data domain, integration with Avamore, all those different cool things that VDP Advanced had are now fully, and all of the scale and sizing that VDP Advanced had available, all of that is now available as part of your Essentials Plus licensing. So
yeah, that is pretty cool. Just getting back to the Linux file system quiescing, there's a question in the chat: which Linux file systems are supported with regards to that? I believe it uses a driver within VMware Tools, but yes. In regards to the file systems that are supported for that quiescing, are you aware of any limitations there?
Yeah, I don't have that list in front of me, but it's included in the vSphere documentation. They've got the specifics about what Linux distros that applies for. And I'm pretty sure it's you know, some of the more, you know, a lot of the more popular ones and current ones that it works with.
Thanks.
Couple other things. There's a process called a full sync that vSphere replication does. That process has been sped up incredibly. There's now also the ability to move replicas without requiring a full sync. So you're able to use storage vMotion for the target, the vSphere replication target disks. And the virtual appliance now runs just the latest and greatest of SLES 11 SP3, which has, you know, better security compatibility, things like that. SRM, there really wasn't that much new for SRM with vSphere 6. Just a few things to point out. Obviously, a big thing was compatibility. It's the only SRM that's compatible with vSphere 6. A new SRA isn't required. There are a few vendors that because of how they wrote their SRA, it was doing a version check. That they're having to rewrite their SRAs, but that wasn't a requirement from VMware. And that won't impact you if you're just upgrading your SRM environment. Some of the big things, though, is integration with a new linked mode in vSphere 6. So you've got a lot better visibility. You have synchronization of roles, permissions, licenses, all of that kind of stuff. And the SSL cert, which was always kind of a pain with SRM, has been greatly improved as well. Really, from a feature standpoint, and this kind of ties somewhat into VR as well. Well, no, this isn't really the VR part. Previously, in SRM 5.5 and 5.8, if you wanted to use SRM with SDRS, the only way that was supported was if you had a consistency group and you created a data store cluster that just consisted of the ones in that one consistency group. So in SRM 6, you can now have a data store cluster that contains one or more consistency groups as well as non-replicated ones. And SRM works with vSphere, vCenter to know which ones are replicated, which ones are not, and when it moves VMs around, storage vMotions VMs around, it will make sure that it never breaks SRM. The other big thing is from a topology standpoint, and this wasn't specific to SRM 6. This was really just more us working with support, working with engineering to some extent, but basically decided that we could support more topologies with SRM. Traditionally, SRM, the options were a single pair of sites, or the idea of a shared recovery model, something like this, where you have remote sites all failing over to a central office. Those topologies are obviously still supported, just a single site, a single pair of sites, and the shared recovery model. The thing that we're supporting now is some more creative plays on that. So if you wanted to do, for whatever reason, maybe you wanted to do a shared protected site model. So instead of protecting your remote sites at one central office, maybe you wanted to, for whatever reason, protect your central office at multiple remote sites. That's supported. If you wanted a model like this, where you have, you've got 3 sites, and you want to protect some VMs from site A at site B, some VMs from site B at site C, and some VMs from site C at site A, that works. The key thing to keep in mind with SRM and these enhanced topologies is that SRM is still a point-to-point solution, and it still only supports point-to-point replication. So you can only protect a VM once. So, in this example, if you're protecting a VM at site A at site B, you can't then protect that same VM to site C, or you can't protect the same VM from site A to site C, as well as from A to B. Hopefully that makes sense. But it does allow you to do some kind of creative topologies if you want with SRM. You don't have to put SRM and vCenter at all of your remote sites. You can play around with it where you actually keep that at your primary site. Reduces the number of vCenter's SRM instances that you have to run, things like that. The web client and the integration with vSphere 6 makes it easier if you're doing multi-site topologies. It used to not give you this kind of detail, but now here you can see it actually shows you the pairing. When you're looking at your site, it shows you not just the name of the site, but also what it's paired with in instances where it's paired with more than one thing. Just really quick, I wanted to talk about SRM 5.8 because didn't come out that long ago. Came out in September, and that was kind of a big release for SRM. Just really quick at a high level, there's a VCO plugin that integrated with vRealize automation, allowed you to plug those kind of capabilities in, self-service VR provisioning into Jira. You can also use that orchestrator plugin by itself. Has a whole bunch of different capabilities for doing inventory mappings, protection groups, recovery plans, things like that within SRM, and you can use that with or without your vRealize Automation Center. There was huge increases in scale from 5.5 to 5.8, and we've carried those increases through to 6.0. So going from 1,500 protected VMs to 5,000, and 1,000 concurrently recoverable to 2,000. Huge performance improvements. So 2,000 VMs with IP customization turned on. Previously, that would have taken 29 hours, now down to basically 14 hours, so cutting that total time in half. But the big thing is from a storage standpoint, cutting that down by 75%, going from 17 hours down to 4. New integrated user interface, we've kind of already talked about that. No more, you don't need the thick client. Everything with SRM is fully integrated with the web client. And we simplified some workflows. IP subnet mapping, if you had to deal with the import-export tool for IP subnets before, subnet mapping is really nice. You just, as part of creating your network mapping, you can assign a subnet map, and SRM will change the network portion of your address and leave the host portion of the address the same. And as you add additional VMs to that mapping, subnet change, or the IP address changing will get handled automatically. And lastly, there's an option of an embedded vPostgres database. Supports any size SRM environment and just makes installation configuration a whole lot easier. So that's what I got. Any more questions?
There's no more questions on the no more questions on the Brownbag Twitter hashtag. No more in there. So that is fine. All right, cool. Thank you very much. Let me flick that over there. Thank you, GS. There's a lot of information there that we can get our heads around. But yeah, I'm sure that if people have any questions, they can contact me, contact GS.
Reach out to me on Twitter.
And we can certainly answer any more questions that people have. So yeah, thank you, GS. Next week, I've got Rawlinson Rivera, the one and only, talking about vVols, and then the following week we'll talk about Virtual SAN, and then Mike and Josh are going to do security and automation the following 2 weeks. So thank you all for attending live, and for those on the recording for downloading in your favorite podcast catching app. And we'll catch you guys all next week. Thank you very much.
Yeah, thanks.